So we just wrapped up the really great Access Anything panel with the MRTK team, and a lot of good questions, and I hope you all got a lot out of that as well. In addition, we also just had a panel a session that was also being held with the Babylon JS team. And I know, Cassie, you had a moment to sit in on that. How were the points that you were able to go see?
I only got to catch a little part of it, but it was really cool to see what they're doing with React Native. So Babylon JS Native supports React Native, and some of the different ways that they're progressing with OpenXR and WebXR. And so it was a cool update, and then I had to dip out, but I'm excited to see the rest once it's online.
Yes, absolutely. And so that session, as well as all other sessions that were only held in person for Mixed Reality Dev Days, will be available on demand next week. So definitely make sure that you check for those. But here is going to be our final conversation for today. Joining us is going to be Andrew London. He is a PM for Azure Remote Rendering, and you held a session earlier as well where you got to share some updates for remote rendering, right?
Yes.
Yeah. So we're going to go into a bit of a deep little session of remote rendering, what's new as well, what are some good use cases, and let's see where the conversation takes us.
Yeah,
so
absolutely.
With that said, could you let the folks know a bit more about what is remote rendering exactly?
Sure. Yeah. So Azure Remote Rendering entered general availability last year, and it's a way that you can upload high poly models, point cloud models to Azure, convert them into your blob storage, and then render them on the HoloLens or Windows desktop. And the reason that exists is because the HoloLens itself has only so much processing power. It can render about 250,000 polygons locally. And so that can be a blocker for key mixed reality use cases.
Okay.
Obviously, designers, engineers, they have these insane poly count models that are sometimes hundreds of millions of polys, or they have these point cloud files that are sometimes billions of point clouds. And so we created Azure Remote Rendering to get around the limitations of local edge devices, so that you can see this like insane level of quality, this really valuable engineering level asset on a HoloLens.
Okay. All right, cool. And I've done a little bit of dabbling with remote rendering.
Awesome.
I think it was last year or so. I co-authored the Learn module that we have for remote rendering, which really provides a nice little intro with regards to what that service entails, as well as some of the benefits. And fidelity is a really big one.
Absolutely.
Being able to ensure that if we are rendering something, you're not losing that quality of whatever the model is you're viewing. And this is an experience that, more than one person, it's a multi-user experience essentially. If someone joins a session, they can also view the model as well, correct?
Yeah, so every device would join its own session, but they're treated as just a normal game object in Unity. So you could use like some sort of networking utility at that point to network those in sessions to network those devices' experiences together, but each device is starting its own session with Azure Remote Rendering.
Okay, gotcha. And then currently, with regards to file types, are there any limitations that are in place in terms of like my models that I could
Yeah, so we support FBX, GLTF, and GLB.
Okay.
And the big news for everybody here was the point cloud support.
Okay.
Which is insane because you can take your LiDAR scan and like a laser scanner from Faro or Navis, one of those industrial grade scanners, or your iPhone, right? They're kind of becoming ubiquitous, those laser scanners. And the data set doesn't have to be converted. You don't have to do any artistry to like triangulate a mesh from that scan. You can take the raw output and throw it up to the cloud and then render it with Azure Remote Rendering. So the time savings is pretty incredible.
That's so cool, because I saw in the keynote you were showing some like scans you said that took like 15 minutes or something to create.
Yeah.
Was that with your iPhone or?
No, I did. I mean, some of my first testing was with it.
Yeah.
But the scans I made for the keynote, I got really lucky. I got to go see the tree houses on campus, which
Jealous.
that was so cool. And it was funny. I just had to set the scanner up, and then I just sat on a bench and like read my phone. Like, oh no, I'm working. But it took about 15 minutes, and some of those scans are like 30 to 40 million points.
Wow.
And so from there, you literally just convert it with our conversion script, or using the ART tool. I don't know if you're familiar with the ART tool. It's the Azure Remote Rendering tool. It's a desktop application that kind of serves twofold. It's open source on GitHub, so it's a great example of how to start your own desktop application that's going to use Azure Remote Rendering, but also like does everything you'd want to do. So you can upload to your blob storage, you can convert, and you can do rendering sessions from within that tool. I don't know what I was talking about, but it's a great way to get started.
that will help you integrate with different devices in order to get that stuff up to the cloud.
Yeah, it's
kind
just
of like
such a
Azure
good
Cloud
quick
Storage,
start.
but with more tooling and things
Yeah,
like that.
exactly.
The emulator, the storage tool that you use for that. So.
Yeah, I think there's a version of it that connects to the emulator so that you can navigate all of your Azure storage from within it too. Yeah.
Cool. Very cool.
Yeah.
And so with regards to point clouds or minus, what's the main benefit of now having that available, that feature?
Well, I would say twofold. One is the visual accuracy, right? No longer do you need to convert to a polygonal mesh, and like that takes a lot of artistry. It takes a lot of pain to figure that out. One of our partners who was in early private preview with us, they said it took their workflow down from weeks to minutes, which is crazy, right? And so you can take this scan and then just have it running on a HoloLens very quickly. Sometimes under 30 minutes, you can do the whole workflow from the scanner to HoloLens, which is kind of unprecedented.
That is. Could you use the Azure Connect too? Because I have an Azure Connect at home. And
I think there's a way that you can export point cloud files from that. So yeah.
Awesome. Like, how do I start? Because I've seen the really cool ones. You have a really cool scanner at home.
Yeah.
You have a LiDAR scanner?
Well, I have the Revo Pop. The scanner.
Oh, okay, cool.
Yeah, I have that, and then of course I have my phone too.
Right.
But I feel like there's a lot of innovation happening in this area of being able to get scans and good 3D models of existing things, because it's so needed and it takes so much time to make this stuff, to do the modeling like you've been doing in Blender. And so being able to scan quickly and then be able to remote render and leverage the power of the cloud on something that wouldn't be able to do that is it adds so much value, and it removes so many of these constraints that we've had.
Yeah, absolutely.
And could you give us some examples of use cases? Like, when would I use remote rendering? When would someone use it?
Wow, there's so many. Like, I'm still learning about it by seeing how people are using it. But some of the main ones that pop into mind are like the AEC industry, so architecture, engineering, and construction. Okay. A lot of them already have these troves and troves of LiDAR scans that they've been doing for surveying, for construction site inspection and walkthrough. That all is super easy now for them because they don't need to go to that polygonal mesh and take that time required. So for those industries, it's really huge. Another cool one is education. I've seen people create scans of these World Heritage sites, and then you can go visit them and their full quality and detail, which is really kind of mind-blowing, right? It's the quality of it and the speed of it that I think is going to bring a lot of power.
We've come back to XR and museums and education a lot throughout our streams because there's just so many cool applications, like being able to visit a place like that in an actual realistic 3D model, high quality, and being able to bring that through a device and enrich learning about something by going there, and you don't have to get on a plane. Yeah. And so it's really cool to see another way that we're starting to push forward education.
Yeah.
That's totally true. We support 2.5 billion points. Which,
that's a lot.
Yeah, one of the biggest scans I've seen was Mount Fuji, and it was 2.2 billion points. And it's exactly like that because at first you're looking at it as like a tabletop. Yeah. And it's like, oh, that's really cool. Okay, Mount Fuji. But then you zoom in, and the detail remains as you zoom in.
Oh my gosh,
and you can see the cone, and then there's research facilities that are up there that I had no idea existed. Wow. And it's all stuff that as you get closer to it, that remain high fidelity because of the nature of a point cloud scan. And we also did a lot of subjective implementation in the way we represent the points and the sizing. Yeah. One of the coolest things I think is I wouldn't even call it a that's not fair to say, but sometimes point clouds are made of circles and sometimes they're made of squares. Okay. And we decided to split the difference and go with squircles.
Okay. Okay.
And the reason we did that is because it's the best blend of accuracy of scan, but also a complete looking visual surface, right? So things look solid if you'd like them to be. And we also added a new runtime API that you can change that. So there's a scalable factor to your point sizing. So if you have a low density scan, but you really want high visual surface continuity, then you could up that number and increase the squircles
Yeah.
and get a nice surface out of it.
I think you just want to say squircle.
I am going to say it as many times as I can.
That's what the squircle.
Squircle.
Yes. And so Mount Fuji is not small. And so I'm trying to wrap my head around, from even a scanning perspective, how does that even work? Like, what do I
Yeah.
need to go out and say, I'm going to
Yeah.
scan Mount
This
Fuji?
is where it gets really cool, right?
Yeah.
A lot of that is done with drones,
Okay.
right?
Okay.
So you have
Yes.
these drones flying around and they're doing LiDAR scanning in a sweeping way. But one of the coolest things I've seen is I've seen a partner who put a Leica scanner on a Spot robot dog.
Oh.
And that Spot robot dog just walked around and got Leica scans from all over the site. And so when you think about the turnaround time, that almost automates your capture of data.
Yeah.
And I mean, at that point, you start to think about having a daily update of your site, right?
Right.
And then if you can get it up to Azure Remote Rendering to render it that quickly, then every morning you could have a fresh scan.
Right.
You can understand what's changed the day before. You could use that for kind of those site inspection use cases we were talking
Yeah.
about.
So I haven't done any of this type of scanning. So when you have like a robotic dog going around, do they, if they go over like the same spot twice, does it matter? Do they have to go through a certain pattern? Do they program it to do a certain pattern so that it doesn't overlap? Or like, I don't really know how that works.
There's a few ways you can approach that.
Okay.
Most of the time, if it's covering the same area twice, you're just adding density to the points, right? So
Oh,
there's
okay.
just that many points to build that portion of the scan.
Mm-hmm.
So yeah, I guess you can have just one spot
Mm-hmm.
and scan as much as you can, but the issue there is a lot of times there's like shadows because it's light.
Yeah.
So it's like
Oh,
shining a flashlight on, let's say, a chair is in front of you and you just get a scan from one source, then everything behind that chair wouldn't get scanned.
Right.
So the best approach is to kind of triangulate your scans, get at least 3 locations around so that you can, cover all those different angles.
Yeah.
So basically, the more I go over it, just the more quality I'm going to get.
Absolutely,
So,
absolutely. Yeah, I came in here on Monday and I scanned one of the rooms that I gave my presentation in, and it was a 40 million point scan, and it took 4 scans. I could have
Okay.
sat there and just like kept doing it from different locations in there and gotten it to like 100 million.
Yeah.
So it also depends on the quality that you're looking for in the end.
Yeah.
Right, because it does take some time. So even the models the real life objects I've scanned to then bring into the computer to create models, I use a turntable, and because my models are smaller, and so
That's
therefore, as the turntable goes, the camera just stays in one spot,
Okay.
and I just let it spin and spin and spin. And the software that I use also happens to give you an idea of like what has been scanned.
Okay.
And then once you get that one angle, then you turn the model a different direction. Because if, let's say, I was doing like a Funko Pop, and so starting out, the Funko Pop was just like standing straight up. Well, if I brought that into my computer to make the model, all we have is just this kind of awkward looking, just this part of the Funko. You don't have the
Oh.
top, you don't have the bottom.
Right.
So now you have a
Okay.
hole.
Yeah.
So then you start moving things around so that way you can capture more images. And so I've done it with that. I've also done the option of more so just taking a bunch of photos. And likewise, the more photos you have, the better you're going to get.
Yeah.
Likewise with the scan, the more times you go around and get scans, the better the quality is going to get. And you do notice that difference if you don't do a lot,
Yeah,
I would
right.
say.
Okay.
Yeah.
And so you're probably playing with like what quality do I need, and then what's the size and performance that I need, right? So you want to
Exactly.
get enough scan to have the detail that you need to have a good
Right.
experience, but you want it smaller so that you can, well, I guess it sounds like it supports quite large. What do you
Yeah,
say,
I mean,
2
that's the
billion or
beauty here.
something?
I don't know how
Yeah.
many other services out there that can render that much. I mean, that even exceeds the local compute capabilities of most machines, unless you've got kind of something crazy.
That's so cool. So like I've been playing with the Looking Glass.
Oh yes.
And
The
they have,
holographic
yeah,
display.
yeah.
It's
So like
cool
I've
looking,
been,
isn't it?
it's so cool. So it's a holographic display, and I've been thinking more about like how they have some really cool tooling to create like holograms with it. Like you use Azure Connect, and they have tooling then that brings that together.
That's
But now I'm
awesome.
like, how do I connect this to Azure Remote Rendering now?
Right,
and I've
right.
like got my me thinking about how I can start using it, because I've actually never used Azure Remote Rendering, but I've seen now some really amazing demos and learning
Yeah.
more about the scanning that you're doing, and that just seems really
Well, let's talk
Interesting.
about how to get started real quickly, because it's
Yeah.
so easy, right? We've
Yeah.
got amazing documentation, and including that amazing documentation, there's a quick start, there's a showcase app, and those are kind of 2 different levels of entry for getting something off the ground. But If you've got a model or if you've got a point cloud scan, you can literally deploy that quick start and have something running from Azure Remote Rendering within like 30 minutes.
That's awesome.
And so it's really approachable. I recommend all of you go check out the documentation on GitHub. I chose it with the wrong camera.
It's okay. I feel like they felt that the call
yeah.
to action. They're like, I'm ready.
Yeah,
they're like
call to action.
They're on the docs already. They're like, yes, sir.
Right. Well, I'm gonna plug another call to action. aka.ms /ARRFeedback. That's our Azure user feedback. So if there's anything that anybody wants to know or wants to recommend that the service has, that's something we're always paying attention to, because feedback from our customers is always number one.
Okay. And so you mentioned Mount Fuji. What other interesting examples have you seen with using point clouds?
Yeah.
Trying to get terminology.
I saw a museum scan, which was incredible, because you can see all the different exhibitions in the museum. So it's like you're kind of at the museum, The other thing that's cool is you can integrate point clouds and meshes at the same time. So they're not like one or the other. You can load multiple, like previously before point clouds, you could load multiple models from your blob storage. But with the point cloud edition, there's a lot of companies out there that have these troves of polygonal meshes, not just point cloud meshes. And so you could take something that's like a polygonal mesh of this table, and you could place it in a point cloud scan of this room. So another cool use case and thing I've seen is people using it for layout fit and kind of understanding the spaces better.
Okay.
I love that. So I can like design my house virtually.
Absolutely,
with this,
yeah. I mean, you could run around it with an iPhone. Create the LiDAR scan, and then you could get any models from Sketchfab or any of these places that are the open markets for models, and then just throw them in there. How's this gonna look?
Yeah, that would actually be really cool. And so, even if we back up just a little bit, by definition, can you define what a point cloud is? Because we've learned about like why it's important to have, but exactly what is a point cloud?
So a point cloud is it's a bunch of different file types. It can be an E57, and an XYZ, or a .ply. I think there's even a couple more, right? But it's the output of a laser scanning device. So that laser scanner, it's literally just shooting lasers all over the room. And it measures how far each laser has an impact. And then a lot of times it'll take a panoramic picture to add as the texture on top of that, so that each point has kind of an RGB value as well. So it's really, the files are actually insanely simple. It's like an XYZ file. It's almost like a CSV file, right? Where it's really just a list of coordinate XYZ axes, and then the RGB color value associated with it, and that's it. So that's the output of those point cloud scans.
Okay, all right. So then from an education perspective, we talked about museums. What other uses could we potentially see, or maybe you've seen for use with remote rendering?
Well, so because it's so high density, if you wanted to show somebody the inner workings of an engine or of a car, you could scan the car and then show that. You don't have to have somebody, in Blender or some other program model something up. So in terms of the ability to capture and then show, I think that rapid ease is probably one of those, opens up that use case.
Yeah, oh yeah, I think that would actually be pretty cool. Because I've done scans beyond just smaller scans that I've had things at home. I've also tried larger things. I think one time I tried like my couch at home, and it actually came out pretty well, I would say, from when I had scanned it. But I'm just still so new to just the concept of scanning objects, and we can actually view them, virtually. But I'm more excited to be able to scan something, and then also someone else also be able
to get the value out of it.
Especially I know for some of the imagery that like we even have in our own Microsoft Photos, where there may have been, I think there's one where there's like a doctor and some of the folks that are around the operating table with like a heart model, I think it is, and things like that. I know we've seen in a previous video we had for HoloLens, the ability to view the parts of the car engine. I've seen that as well. So it's just really cool when you're able to actually get that. You're able to also kind of like bypass the whole, now someone needs to create the model.
Yeah, exactly.
part.
That's that artistry part, right? Because that requires a very specific skill set.
It does.
Right? And that
yeah.
person is making trade-offs when they're doing that because they're
Yeah.
saying, okay, I'm going to lower this, or just to triangulate this, that's going to kind of obscure this corner.
Right.
So by being able to kind of cut that out entirely and go from scan to render,
Yeah.
that's going to be beneficial.
Right, and even for instances where someone does need to actually create a model, you just brought up a good point, and this is how it was explained to me when I first learned about remote rendering, is that thanks to remote rendering, the artist doesn't necessarily have to worry about cutting out certain things that they know would make the model heavy. So
Right.
if we refer to the medical field, if you are preparing for a surgery,
Absolutely.
but you want to test things out with an actual heart model,
Yeah.
you probably need some of those things that are actually on a human's heart to like know that you're probably
Right.
doing like surgery.
You don't want to retopologize a heart.
Exactly,
Right? So however that
right?
data comes out, if you can get that as a point cloud
Yeah.
scan, that would be a very critical use case.
Yeah, so I think that's pretty good. I think when we all venture back home from dev days, it'll be fun
Yeah.
to try out some remote rendering.
I just see somebody at a computer and they're like, that artery's not important.
Can you imagine that?
And you're like, wait, I think that artery
Yeah,
might
I
be
think we
important.
kind of need that one.
I feel like you guys are adding like more XR devices that I need to buy because I don't have I have Azure Connect. I'm like I can scan with that, and I can make the quilt images for the looking glass, but these like scans that you have, but see the thing is I love to like buy all the things, and then like the time to actually play with them doesn't exist.
They're two different things. The energy to explore, and then, the energy to purchase the things that are needed to explore,
Yeah.
and the energy to use them to explore. I run into that all the time. I've got like a lab full of toys.
Yeah.
I don't touch it.
Oh, same, my desk, and I have I got the Motion Leap controller. I got so many cool things on my desk that I don't have the time to play with, and now
Right.
I think I have to get some.
Well, this shortens the time, so you have no
Yeah.
excuse.
That's true, because it's going to save me time so that I actually can play with the
Yeah.
devices and use Azure Remote Rendering. And I'm starting to think about what I want to build with it, because it sounds like such a cool service. So cost-wise, is there a free version that a lot of the different Azure services have you can try it out for free, that type of thing?
Yeah, when you sign up for Azure, if you're
Yeah.
a new user, I think you get a certain amount of credits.
Yeah.
Okay.
So that would be the way to go.
Okay, cool.
Because it's pay as you use it,
Okay.
right? So
Okay.
when you start a session on the either standard or premium service, then you just pay for the hour that you use it, right?
Okay, so in that the paying using for how much the storage is through Azure Storage, so you're actually paying for when you're actively using this service.
Yeah, when the
almost
session
like Azure
starts
Functions.
and for conversions. Yeah.
Yeah.
Oh, okay, cool.
So and in that Learn module that I mentioned earlier, we do have a sandbox environment in there, so that way folks could try out remote rendering. And
Boom.
if you do the
Oh,
module
yeah?
Learn, we
Sweet.
set up the sandbox in there so you can give that a try.
That's awesome.
So it's something that you can definitely try out. Speaking about just devices accumulating a lot and then trying to find a time, I found what's been helpful for me is to try to tie it back in to creating content of some sort. I know we've talked about a lot of content today.
Yeah.
So having a need to tie it into something that we want to publish and put into the world, that's the way I get around doing that. But I too have a closet at home of
Nothing motivates like a
things.
deadline,
Yeah,
right?
exactly.
This thing I've been wanting to learn Unreal for a while, and then I had something to actually build
Oh,
with
man,
it now.
yeah.
So that's how I
Yeah.
finally did it. It's having the goals and being able to tie it into work and
Right.
things that you're creating is a good way to do it.
Absolutely.
Yeah.
And so just before we close out with you, I'm just curious because I know you're newer here for us here at
Yes.
Microsoft, but tell us a little bit about your background for a little bit.
Yeah, so I started as a developer in about 2014.
Okay.
I saw the Kickstarter for the first Oculus Rift, and that was kind of a moment in time for me. I knew spatial computing was obviously going to be the future of the industry, and so I started
Yeah.
learning JavaScript, I started learning C#, became pretty proficient with Unity, and then from there I went to a startup where we were building healthcare-focused applications, so we built things for Gear VR and other headsets, and that's where I actually started working on the HoloLens for the first time.
Oh, wow. Okay.
And from there, I was a field engineer for a while, supporting different AR SDKs, and got lucky enough to get get this role here.
Yeah.
That's cool. So we have another non-traditional background on the show today.
Oh yeah,
Right?
absolutely. My
I love
degree's in
that.
speech pathology. So.
Yeah, that's so cool.
See, we're everywhere.
Yeah,
like the
for
non-traditional
sure.
background, everywhere, you just don't know until we ask, right?
Yes, absolutely.
But that's so cool. So you were like inspired by VR. So like VR is what
Yes.
made you get into the field.
Yeah.
Like, that is really cool.
I'll admit I loved computers, but I didn't have that thing to get me over the programming
Yeah.
learning hump.
Yeah,
you know?
that's fair.
And
Yeah.
then I saw it, and I was like, oh, that's the Matrix. Okay, I'll code whatever I
Yeah,
need to
let's start
code now.
doing it.
Yeah, and
Yeah.
that really got me through it.
Because I know eventually I'll just be able to plug in and then
Yeah,
Yeah.
absolutely. Yeah. Jump into this
just
world
in the
that we
back.
make. Yep, absolutely.
Well, thank you very much for the
Yeah.
background. Thank you for more information about remote rendering, though,
Yeah,
because
absolutely.
it's a really great service that I know I don't spend a great deal using it, but it's something that, you know, I have some familiarity now with point clouds. Now that we know more about what that is,
Yeah.
why it's important, it's something that we can start doing a bit more with, I feel like. But I would say just overall, I'm excited to, you know, see what's to come, not just
Yeah.
with remote rendering, but really all of our mixed reality
Absolutely,
services,
right?
you know, because
Yeah.
Yeah, I mean,
there's so much happening.
that's right. Like if you think about all of the things we covered over the last 2 days, all of the
Yeah.
sessions that weren't even live streamed, there was even more than that. Like there's so much exciting
Yeah.
things happening and so many ways, things that have been made easier. Like you were talking about that programming like hump to get you started. Like when you started, it was still really hard to build things in VR. Like,
Yeah.
and now there's so many tools that we've talked about.
Here's
like
a tool. Here's a tool.
Yeah.
Just
Yeah,
press
you get a
button.
tool. You
Yeah.
get a tool.
Everybody gets a tool.
Well, and the
Yeah.
last point I want to make is that
Yeah.
we're always really passionate about Azure Remote Rendering. It's not something
Mm-hmm.
we just built and shipped and walked away from.
Right.
We're constantly making improvements. We've lowered session times. We're always increasing the capabilities, improving hologram stability. So just there's more to come. We're going to
Good.
stay on it, and there's going to be some really cool things.
Yes. Well, thank you very
Yeah,
much.
thank you for
This-
having
is awesome.
me.
This has been a super exciting past 2 days with Mixed Reality Dev Days, and I'm happy that we're able to have had this event hybrid, both in person as well as virtually online with Learn TV. I feel we've had a great chance to speak with folks from the Mixed Reality Toolkit, as well as just the Mixed Reality team overall, and we've definitely learned a lot. There's a lot still coming down the pipeline. MRTK3, as announced, is currently in public preview, so that's super exciting. You can definitely get those packages within the Mixed Reality feature tool, and that's where you can find all of the different packages that are available with MRTK3. Don't forget about the hackathon that kicked off yesterday as well. There are about $17,500 in prizes, and so ensure that you are taking part in that. It's open to everyone. We just really want to see what you create. In addition to that, all the videos that we have recorded, both in person as well as virtually, they are going to be available on demand. So next week, definitely follow up on our platform so that way if you missed a session or you weren't here to view one in person, you'll be able to check that out. But I will say we've had a really great Mixed Reality Dev Days. I'm so excited that I've had a chance to come be on campus with everyone. And until next Dev Days, take care and happy creating.